Okay, here's 921. We have a light emitting diode. That's what these two little arrows are. And we have a circuit. We've got 10 volt voltage source, 2.5 kilo ohm resistor. We've got a characteristic curve that has more markings on it than this does. Just didn't draw them all in. And we're supposed to draw the use this to find the operating point. And so the first thing we do is we look at our circuit and we do a KVL, and so we know that the voltage source equals the resistance times the current through the diode plus the voltage across the diode. So the two voltages of these two items have to equal the voltage source. Now we say, well, what happens, what do we get for I if V is 0? So if V is 0, then I get 10 volts equals 2.5 kilo ohms times ID, or ID equals 10 over 2.5 K, which is same as 104K, which is, no, 100 over 25K, which is 4 milliamps. And so that gives us our first point. So this graph went up to 5, and so we have, well, it's not very good, but 4 milliamps. So I was in milliamps. Okay, now we say, well, what would happen if the voltage across our diode was 5? So if the voltage across our diode was 5, that was at the other end of this graph here, then the current through this resistor, which would be the same as the current through the diode, that current would be 10 minus 5, beginning voltage minus ending voltage, over the resistance, 2.5 kilo ohms, or 5 over 2.5 K. That's the same as 50 over 25K, which is 2. So at 5, I would have 2. So then I would draw this line, and then on this particular graph, I'd see where they would intersect, and on, of course I don't have it exact up here, but you would find that point, and that would be the operating point.